Going on, guys? Let's do this problem right here. The question is asking find the arc length of the curve on the given interval. So we have this expression right here. So let's see how we can find the arc length of this curve. So the first thing is we have to know the equation of the length. So the equation of the length is integral a to b square root of 1 plus y prime square dx, right? So dx, this is the equation we are going to use to find the length of this curve. So let's apply this one. But before we do this, what we can do, we can find the y prime separately, and then plug this into this square root. So let's find the y prime first. So y prime is basically ln sec x. So we have ln sec x. This is the one we are going to find the derivative. So if you find the derivative of this one, this is going to be basically 1 over sec x, right? 1 over sec x, and also this is a chain rule. This is outside derivative, and inside derivative is going to be sec x prime. So sec x prime, and if you find the derivative for sec x, that's going to be sec x tan x. So we will have sec x tan x over sec x. Here sec x cancels. We are left with y prime is going to, we are left with tan x, so y prime is going to be equal to tan x. Now if you notice, we have to square this one, so y prime square is basically tan square x, right? So now we have to go and plug it in this equation. This is going to be L is equal to going from 0 to 5 by 6. That's our limits of integral, that's given right here. So 0 to 5 by 6, and in the square root we are going to have 1 plus this y prime square, that is tan square x dx, right? And if you know that 1 plus tan square x is equal to sec square x, we can substitute that one instead of this one because we want to get rid of this square. That's the main thing. So 0 5 by 6 sec square x dx. And if you wonder how this sec square come from, you can write this sine square x plus cos square x equal to 1 and divide everything by cos. You will get the relationship. So we have this one right here. Now this is we can get rid of this square root right now. And also if you notice, the limits of integrals going from 0 to 5 by 6, so the answer is going to be positive. So we don't have to worry about the absolute sec x. We can just directly put positive sec x. So sec x dx, and the integral of, if we integrate sec x, that's going to give us ln sec x plus tan x, and that's going from 0 to 5 by 6, right? So this is what we get, and from here what we can do is we can sec x plus tan x, yeah, we can directly substitute the values. So let's substitute this 5 by 6. So we have ln sec 5 by 6 plus tan 5 by 6 minus ln sec 0 minus it's also plus, right? Plus tan 0. That's going to be the value. You have to figure it out. So let's find this one. So ln and sec 5 by 6. Sec x reciprocal of cos. If you know that cos 5 by 6 is root 3 by 2, sec 5 by 6 is going to be 2 by root 3. And here we have to divide by sine 5 by 6, so cos 5 by 6, that's going to give us 1 over root 3, right? Because sine 5 by 6 half, cos 5 by 6 root 3 by 2, so 2 cancels, and you will end up with this. Minus, here we have ln sec 0 is basically 1 and tan 0 is equal to 0. So we have this one right here, log. Okay, so let's do the simplification. So this is going to be log 3 over root 3, and the other side we have minus log 1, right? Log 1 is 0, so you can cancel this one right here. And also if you notice the 3, we can write 3 as root 3 square, same thing, right? So you can put root 3 square and cancel this one. So root 3 square over root 3, so root 3 square cancels, and the final answer is going to be log root 3, and that's the length of this curve that's provided by this expression. And I hope you guys find this video helpful. See you next time.